What's up, guys? Mr. Jones here, and we are on to Unit 2, which is transformations of functions. Okay, so on my YouTube playlist for this unit, I included some review videos for Algebra 1, talking about domain and range and just what a function is, all that stuff. So hopefully that makes sense to you, and you're refreshed on that. But now we're going to be talking about the stuff that's new for Algebra 2, which is how we transform some of these functions, some of these different functions that we see. To start that, we're going to talk through parent functions. And what a parent function is just kind of like the standard default function of what these different types of lines and graphs look like. So all a transformation is just basically kind of taking these kind of standard graphs of these different types of functions and shifting them around the graph. Okay, but what we need to do is understand what happens to the equation, kind of the base equation that makes the transformation happen. What is it that makes it shift in all these different directions? So the first thing we're going to do is just there's 6 different types of graphs, and we're just going to walk through each one, kind of what the standard of that graph looks like, and then we'll slowly get into the different types of transformations that there are. So the first of those you should be familiar with as well is a linear equation. Okay, so you might remember that a linear equation is just the graph of a line. So, and it helps to know kind of the basic shape of it, right? So the standard line kind of goes diagonal. And so the standard linear equation, you might remember y equals mx plus b is the equation of a line. But the equation, kind of the standard, very standard, like the most basic linear equation would just be y equals x, okay? Because the key of a linear equation is that the exponent on the x, the highest exponent that it has is 1 on a variable. And that's going to be a big deal because a lot of the other graphs that we look at are going to have different exponents there, okay? But kind of the standard linear equation has just x to the first. To kind of illustrate what happens, right? We are going to just pick 5 x values, and kind of the standard x values to choose would be -2, -1, 0, 1, and 2. And so we're just going to think about, okay, if these are the x values, and I substitute these x values into the equation, what would be the resulting y values, okay? And this one's super easy, right? Because with the equation y equals x, they're just the same, right? So if x is -2, there's no real math to do there, right? So because y and x are equal. So for every x value that I have, the y value is just going to be the same, okay? So -2, -1, 0, 1, and 2 would also be the y values for that. And that would be true for every, that's not just these 5, but every y value and x value, right? They would all be matching. So thinking about what that would mean for how my graph would look, right? Why it looks that way, like a straight line, right? The point, -2, -2, on my x and y axis, right? On my right, -2, -2 would be there. -1, -1, 0, 0, 1, 1, and 2, 2. And you're going to notice something as well, that all of these parent functions are going to go through the origin to a certain extent, okay? So that's something that we're going to talk about a lot is that origin, kind of the center of the graph, okay? That's why we choose this range of values, because the origin point is going to be right in the middle, and then we're going to look at how all the other points kind of come from that, okay? So that's what the standard line looks like, okay? Again, going diagonal like that. And then the domain and range, again, you should have hopefully watched an Algebra 1 video to review this, okay? But both the domain and range, again, the question we're asking there is, what would, like, as this line extends forever and ever, or what are all the x and y values that this line would touch eventually, okay? And right, it's going to extend forever side to side. So that means the domain would be, I say ARN, standing for all real numbers. And then the y value, up and down. It's going to go down forever and it's going to go up forever. So that also means it's going to hit all real numbers. So those are that's the linear parent function, kind of all the characteristics of that. Number 2, absolute value. What's an absolute value equation? So the absolute value, kind of the standard equation, would just be y equals the absolute value of x. Okay, so not too different than the linear equation, but it's just the absolute value of x. And that's going to change things just a little bit. Let's get the table of values in there and just see what this graph would look like. Okay, so if I choose the same x values, -2, -1, 0, 1, and 2, thinking about that, if I substitute those in for x, right, remember what absolute value is. Absolute value is, right, it's telling you a number's distance from 0. So basically, the easy way to remember it is If you put a number in the absolute value, it always comes out as positive, okay? So the absolute value of -2 would be +2. The absolute value of -1 would be +1. Absolute value of 0 is 0. And then if I put the positives in there, they also end up being positive. So just a little bit different, right? Basically with absolute value, we don't end up with any negative answers, okay? So thinking about what that graph would look like, -2, 2 would be up here this time. -1, 1, 0, 0 again in the origin, 1, 1 would be here, 2, 2 would be here. So those are the points that form my absolute value equation. Again, it's not just those 5, it's going on forever. So you can see that instead of a straight line, right, instead of a straight line, it kind of forms a V, okay? And that's true of all absolute value graphs, is that's kind of the V-shaped graph. And then so thinking about the domain and range for these as well, what would that be? Well, again, domain, we're thinking, okay, side to side. Is this graph going to extend forever to the left? Is it going to extend to forever to the right? Yes, it is, right? This is going to go forever in both of those directions. So that domain would be all real numbers, okay? But the range, if I ask myself, is it going to extend up forever and down forever? No, it's not going to hit both of those, right? It is going to go up forever, right? Because these arrows are kind of pointing diagonally to the sides and up. So it means it is going to go up forever to positive infinity on the y-axis. But it does not go down forever, right? There's like a lowest point that it hits, okay? And that would be right there, right? It never goes below that on the y-axis, right? So how would we say that? Well, we would say y is, right, it's that lowest point on the y-axis is 0, and it's all the numbers higher than that. So y has to be greater than or equal to 0. And that range can change depending on if we transform this function or if we shift it around a little bit, but just that's the general, again, that's the characteristics of the parent function of an absolute value, kind of what the standard absolute value graph looks like, okay? So that's the first two. Let me erase this and we'll do 4 more.